Okay, so we're starting about map. In Java, another interesting collection, broadly speaking, is map. The data type is officially known as associative array, but that term is rarely used. A more common alternative name is dictionary. So the name of the interface is map. The name of the data structure is associative array, and it is really common to see dictionaries. So all of these terms are talking about the same thing. So whatever is map or dictionary, it is the same on Java. Okay. So inside a map, data is stored in key value pairs. The keys and values can be any object, numbers, strings, or objects of other classes. So we have been talking about types. Okay, so whatever we talk about numbers or strings or booleans or anything else, we're talking about types. Okay, so the keys and values can be any type. All right. And just to remember a little bit, let me show you right here the structure that we have of the collection hierarchy. So last lesson, we talked about this representation right here. So we have basically two, three, uh, two trees of elements. So we have the collection as the root for one, and then we have the set, queue, and list, and this other structure right here, which is the map. So map, it is really different from everything that we have studied so far. Okay, because we have two structures associated. We have the keys and values. And the options here are hash table, hash map, and the tree map, which can be sorted. Okay, and please remember about this name, sorted, because we are going to talk more uh, about the keys and sets that also can be sorted. All right. Okay, so back to where we were. Hash map is the most common class that implements map and that we use in most of our applications. So the hash map class is the most popular kind of map collection. On the one hand, it is very similar to hash set and has all its methods. On the other hand, it's like a list, array list that can use objects as its indices. You can create a hash map using the statement like this. So the class hash map, the generic symbol, and then the key type and value type, which can be everything, if any value type that you want, the name of the variable, and then the call to the constructor to create the instance. All right. Okay, so before we show some useful methods, let me show you right here an example or on how to use the map. Okay, let me change this to map. All right. So right here, as usual, I always have been encouraging you to apply the polymorphism principle and not use hash map. Okay, because the hash map is the class and the map it is the interface. So because we have a lot of uh, not a lot, but some classes that implement the interface map, it is really useful to keep the type of the variable as map, and then we can really easily change the implementation type. Okay, so in the same way that we did before, then we did like a list of strings, and we could do like new array list And then we could easily switch to not anymore a array list, but now linked list without needing to change anything else in our code. Okay. So in the same way, I encourage you to use map and hash map, not hash map on both sides. Okay. And this is uh, the application of the polymorphism. Okay, so we have different instances, but all of them we are dealing with like map. Okay, so we are working just by the interface. All right. Okay, so right here, what I am doing is like to define associations on some countries right here. I think those are the most demographic uh, countries. And then, so we have the name of the country and then the population. So here we are storing a text, a string, and a number. All right. So that's why we have a map of string and integer. If we wanted to store like booleans, so is that a big population or not? So we needed to change right here to the specific type. So the first one is the type of the key, and the second is the type of the value. All right. So always key value like a dictionary. Okay, so if you take a look on the dictionary, we have some words and then we have the definition or the translation. So the idea right here it is key and values, and we need to specify both of them. And it really could be anything. So it could be string. Okay, so I think you got the idea. But for our example right here, I am defining string integer. Okay, and please take a look that it is integer with capital letters, so it cannot be like int, because int it is primitive type, and we are working only with objects. So everything needs to be classes. That's why we studied before about the wrapper classes. Okay, so if they are numbers, so use integer. If you are going to store really long numbers, so change it to long. All right, but in this case right here, we have just 1.4 billion, so it is enough to use the integer type. Okay, so we have China, India, United States, Indonesia, Pakistan, Brazil, and Nigeria. And then I started all of those uh, countries using the method put. So the method to insert something, to add something to your map, it is put. Okay. So as you can see right here on the documentation, if you move over the mouse on the method name, so we have here the descriptions. So it is put, and then we have K and V, which K is for key and V for value. And you can see that it returns the value. So we could do like uh, in China population, population, and then assign, because here we have the return of the value. Okay. In our case, in our example right here, there is no need to do this, so I'm gonna just remove. And it is really interesting map data structure because we have inside two data structures. We have a collection of keys, and also we have a collection of values, okay? And they are related one to the other. So we have here the collection of keys, which will be China, India, United States, all the keys, and then a collection of values, which will be all of the population counting. Okay. So if we want to see just the keys, we have the countries dot key set. So please take a look that it is not a key list, but it is a key set, which means that there is no um, control of the order that we are going to read those keys, and they are unique. So every single key in our map, they are unique, okay? Because we already studied about the set structure. And I'm gonna add right here a breakpoint. Let me do this, think this. I'm gonna add right here the breakpoint so we can see only the output for that. Okay, let me run that. Let's take a look on the output. All right, so as you can see, the order that we entered the elements, that we added the elements were different. We added the first China, and the first one that we got here is Pakistan. So it is in a totally different order, okay? And look, here we are iterating over the key sets. So the key set, we have all the keys, and then we use the method get to retrieve a specific value. Okay, so get is similar to what we have in the on the list. Okay, so when using uh, array lists, we had there the method get, which we could provide the index, the specific index to read or to get in specific elements inside of the array list. And here we have the get receiving not the index but the key. So based on the key, the uh, the Java just goes inside of the map looking for that key, and probably the first one was Pakistan, and then it iterates right here and see, oh, Pakistan, the value is this one. So it is right here, okay? It is the same that we do with a dictionary, okay? So if someone says to you, what's the definition of the word and give you a word. So you are going to iterate over to run over the pages of your dictionary and look for that specific word, which will be the key, and then we'll see. You're going to answer. Oh, the definition for this word is, and then you say, all right. So it is based on key and value right here, and then we use the printf command just to format like this. So we have the key and value being printed, and then the percent %n to break line. That's why we can print all the elements. So now we already know the method put to add elements into our map and the get method to retrieve given a key. So we pass the key right here, and then we get back the proper value. All right. But this construction of the, oh, there's a question here. I don't recall the printf syntax. Okay, so first comes a string with the format, the output format. Okay, and then we have all the provided parameters. So I provided here two placeholders. So I needed to provide two values that will be replaced on the placeholders. Okay, this is the printf syntax. All right. So if I pause my mouse here, we can see that first we have the string format, then all the arguments. And the count of arguments are based on the count of placeholders that you place here. So here we have the string and a number. The %n is not a placeholder, it's just a symbol to represent the break line. Okay, we could do also like this, /n. Okay, and the difference is that the %n, in the case of the printf, it is universal for whatever operational system you are using. So I prefer to use the %n instead of the \n. All right. Okay. So as I was mentioning, we have the key and value association. And this construction of the key and value, it forms another collection, which is entry. So what are entries? They are the association of key and value. So in a map, we have three collections. We have the collections of keys, we have the collections of values, and then we have collection of entry, which are keys and values together. All right. But for keys, we know it is a set, so all the elements are unique and they are not ordered. The values, I think it is a list. I'm not sure of that. Let me take a look. And for entries, we have also a set. So every single pair is unique. All right. We cannot have duplicated pairs. So to know all of this, I always recommend you to explore all the possibilities right here, which we can do, placing the cursor right here, just after the dot, and then control space, and then we have a list. So we have the key set, which is a set. We have the entry set, which it is also a set. And for the values, let me take a look. Oh, right here, values. Which is actually a collection. So it's not a list, it is a collection, which we know it is a super type of list. So it is collection, okay? Please remember that list it is an interface that inherits from collection. So collection, it is a super type of list. All right. So exploring the entry set. So what we have, it is, I know it's a little weird, it's map.entry. So let's take a look on this guy, entry. And you can see that it is inside of the map file right here. So map.java on the line 427. And what we have before, we actually are inside of the map interface. Okay, we have right here the interface map, and then right here below, just scrolling. So, oh, what is that? It is right here. Okay, so interface entry. So we already studied about inner types. Please remember everything that we have been studying. It has a logic of things. So we first study a topic, then a topic that uses the previous knowledge. All right, so interface, and it uses the generic, so K and V, which means the key and value. All right, so here we have the get key, which returns the type K, get value returns the type V, and so on. Okay, so in this way, we are exploring both of the contents, keys and values. In the previous one, we were just iterating over the keys, and then we used the get to retrieve the value. But now we can explore both of them. So we can test like this, we can, uh, oops, we can define a conditional and if test. So if the key of the country contains S, so print them. So first we printed everything, and now we'll just print the countries that have S in the name. Okay, so just running here in debug mode so I can stop on the line 39. So just the countries that have S in the name. So take a look again. China doesn't have S, India doesn't have, Brazil doesn't have, neither Nigeria. So just Pakistan, United States, and Indonesia, and they were printed right here. Okay. Again, the order it is a little mixed because we are running over a set. Then we don't have the assurance of order. It is not sorted. Okay. All right. Uh, so right here, I first tested over a key, but we also can test over the value. So now we are just going to print the elements that have values beyond 1 billion. Here on the console, we have just China and India with populations over 1 billion. All right. There's a question here. Can you say interface behaves like a class? The interface is an inner interface. Yes. I told you before about the class, the abstract class, and about the interface. Please remember about that. And an abstract class, it can contain uh, it can contain abstract methods, but it is a class. And an interface, it is like all the methods are abstract. All right, so In this way right here, all the interfaces are abstract classes, and of course they are classes, okay? It is just a kind of restriction. So all the interfaces are abstract classes, and all the abstract classes are, of course, classes. All right, please remember that. So if we can define inner classes, yes, we can define inner interface. We can define inner enumeration and so on. All right. And the syntax right here, map.entry, it was on purpose. You could just do like map.just entry, and the difference will be about the import. So instead of just import you to map, you needed to map.entry and then import, and it is fine. Okay, so I did on purpose just to show you that it is an inner type. Okay, so I'm doing everything. I prefer in this way to be really clear of what kind entry is. So where is the entry? So map.entry, I prefer this way to be really clear to other developers that are reading that code. All right, so we already know, but to add the parse key value, we know the get to retrieve given a key. We know the key set, we know the entry set, and also we know the values. All right,